Okay, so how is everyone today?
Wonderful.
Wonderful. All right. So we had been talking about. Oh, the thing's not down. We had been talking about the plane and graphs and things like that. All right. So here we are. Today's what, the 19th? Yeah.
Yes.
All right. So to remind you, if you have an equation in one variable, the set of all inputs such that the equation evaluates to true, that's called the solution. And then if you have an equation in two variables or more, two or more, the set of all inputs such that the equation is true is called the graph. So that's the name. And so notably, graph is a set, and it's not a picture in particular, it's a set. But very often it's useful to draw a picture of a graph, and then what's that called? Starts with P. Plot, yeah. Okay, so then it's a plot, right? So a plot is a picture, a graph is a set. All right. So concerning lines, every line is the graph of an equation of the form a multiply x plus b multiply y equals c, like that. And there's a condition on this, is that a and b are not both 0. And understand what that means. It means that it's fine if a is 0. That's fine. But if a is 0, then what? Then b isn't. And similarly, it's fine if b is 0. But in that case, a isn't. And it's also fine for neither one of them to be 0, right? They could be a and b could be like, 1 and 2. But they can't both be 0. All right, so then because that's the case, because that's the definition, there's in fact 3 cases. Let's consider the case. So I'm going to make 3 columns here. 1, 2, 3 columns. So let's consider the case when a is 0. So if a is 0, that means b isn't, right? In consequence. But if we plug in a equal to 0 in that equation, then the equation becomes 0 plus by equal c. Okay, because we plugged in a is 0. So then by is c. And now because a is 0, that means that b isn't, which means that it's permissible that we can divide both sides by b. So if we divide both sides by b, what's the left-hand side? It would just be y. And then what's the right-hand side? C over b. Now here's the deal: is that x and y are the variables, and a and b are constants. A, b, and c are all constants. Now I know that usually you consider a letter to be a variable, but it's not. X and y are the variables, and a, b, and c are some constants. Since c is a constant and b is a constant, that means that c over b is a constant. That's what that means. So what I want you to observe is that when a is 0, this equation is of the form y equal a constant. So we can plot that. That's easy enough. So for example, that constant might be something like 3. So if I put some marks on the axis here, so that point right there, its y value is 3. What's its x value? 0, right? Because it's on the y-axis. If I move over a little bit, this point right here also has y value 3. You know, maybe that's x is 1. So maybe that's the point 1, 3. And then if I move to the left a little bit, this might be the point -1, 3. But all of those points that I've plotted, they all have the same height. So the line, y equal constant, if that constant happened to be 3, would be this one. So that's all the points that are at that particular height. Okay, and this is this is called the horizontal case. You know, because the plot is horizontal. All right. So that's the case when A is 0. What about the case when B is 0? So if B is 0, then what about A? It can't be 0. So if B is 0 in this equation, the result would look like A multiply X plus 0 equals C. So A multiply X equals C. And because B is 0, A isn't, which means it's permitted that we can divide by A. So X is C over A. And again, C and A are constants. So this is an equation that looks like X equal a constant. And again, we can plot. So maybe that constant is something like -2. So on the x-axis, I could make that and that and say, well, on the horizontal axis, that's where x is -2 right there. So besides that point that I marked, are there any other points that where x is -2? I'm not sure what you mean. So like the points on the y-axis, these x is 0 for all of these. So here's a point where x is -2. What about the one immediately above it? What about that point that I'm pointing to right there? What's its x-coordinate? Also -2, right? And the one above that one, also -2, etc. In fact, all of these have the same x value. All right. So what we're observing here is that when you have an equation that looks like x equal to a constant, the line will look like this. So this happens to be, the one I happened to draw was x is -2. If x was positive 5, it'd be over here. All right. So if this first one was called the horizontal case, what about this one? Yeah. All right. Then we said, well, let's consider when A is 0, that was that. When B is 0, that's that. It's not permitted that they should both be 0. So the only other possibility concerning 0 or not is that they're both non-zero. So that means A is non-zero and B is non-zero. All right. To analyze this case, I'd like for you to consider, let's find the intercepts. So in particular, I'll start out by finding the x-intercept. So what is the algebraic condition for an x-intercept? What must be true when y is 0? Now that's its name because, taking the usual name for these axes as the x-axis and the y-axis, to be an x-intercept means that you're touching the x-axis, which means that your y value should be 0. So an x-intercept is when y is 0. So I'll take this equation and plug in y is 0. All right, so plugging in y is 0, obtain ax equal to c, like that. And then since they're both non-zero, that means that a is non-zero, which means that I can solve for x and obtain this. So as a result, what's the x-intercept? You got to be a little bit careful because remember, an x-intercept is a point. So it's not c over a. Yeah, it's c over a, comma, 0. Okay, so that's the x-intercept. Similarly, y-intercept. So what is the algebraic condition for a y-intercept? Well, that's when x is 0. So I'll take that equation, plug in x is 0. Since I'm considering the condition when a and b are both non-zero, that means I can divide by b to obtain y equals c over b. And therefore, what is the y-intercept? Very good. So as a result, we can make a plot. And we have two intercepts. So now, before I get any further, I'd like for you to consider these two plots right here. So notice that this plot, does it, do you observe it has a y-intercept? Yeah, right there, right? And do you also observe that it has no x-intercept? It doesn't have one. That is to say that this red never touches the x-axis. And this one is the opposite. It has an x-intercept but no y. So this case is going to be the case when we have both an x-intercept and a y-intercept. So, just to draw something, I'll say that that happens to be the y-intercept and this one the x-intercept. So some point on the y-axis and also some point on the x. Okay, this point here is c over a 0, and this point here is 0 c over b. So this the first case we considered is called the horizontal case, this second one the vertical case, and finally this one is called the sloped case. Good. So every conceivable line can be expressed in that way. So any question about this? So the main task is that what we're going to do is we're going to describe a line somehow, one way or another. We're going to describe a line, and it's going to be your job to come up with its equation. So that might be something like I give you a picture of a line, and from that picture you're supposed to come up with the equation. Or I could somehow otherwise describe the line, and you're supposed to come up with the equation. All right. So to that end, we have this concept called slope. So I could say let L be any non-vertical line. That means that it's fine for it to be the horizontal variety or the sloped variety. It just can't be the vertical kind. And I could say let x1, x2, x1, y1, x2, y2, and x3, y3 be any three distinct points. What I mean is that you need to select 3 points, and they all have to be different. It's not allowed that you should pick the same point twice. All right. So if this is the line, something like this. So that's the line. And then now we have 3 points. So I'll say, you know, here and here and here. So this one will be x1, y1. This one x2, y2. And this one x3, y3. Now, in the same kind of way we dealt with distances and midpoints and what have you, you know, we made all those grids and rectangles and right triangles and things like that. So, that being said, I'm going to do this part quickly. Observe that for these 2 points, that we have this right triangle right here, corresponding to just those 2 points. Okay, and you can imagine that the way I did it is I projected them down to the horizontal, made measurements, and then went back up, and then over to the vertical, made measurements, and then went back. All right. Similarly, we've got this little triangle, and then we also have a bigger triangle. This one right here. And they're both right triangles, one contained in the other. Now this angle right here between the horizontal and the line. So do you observe that that angle is shared between the little and the big triangle? They're the same. And that means that concerning the big triangle and the contained triangle right there, they both have that angle, whatever that is. They both have a right angle. So what does that mean about this angle and this angle? Those are also the same, right? So this has to be the same as this one. Alternatively, you can imagine that these 2 vertical lines are parallel, and here's another line cutting them. So you know, there's a geometry rule which says that those 2 have to be the same. So these triangles are not the same triangle. They're not the same, but nevertheless, they have the same angles. The angles are the same. So 2 triangles that have the same angles are said to be what? I'm fishing for an S word. Which one? No, not that one. Starts with S. I'll do it. Ends with imilar. Okay, similar. Similar, right? So here we have 2 similar triangles. And well, one of the things that you know, you're required to know about similar triangles is that ratios of analogous sides are equivalent for similar triangles, which means we can make ratios in the one triangle, and the ratio should be the same in the other. So this length right here, really, what I am interested in is signed distance. So what is this this length right here? Well, that'd be x2 minus x1, right? And be advised that that is that's signed, right? Meaning that I'm not putting it inside of absolute value. Similarly, what is this measure right here? Yeah, this would be y2 minus y1. All right. And so that's the for the little triangle, x2 minus x1, the base of the little triangle. So the base of the big triangle what's the measure of that? Very good. So that's x3 minus x1. And the height of the big triangle? Very good. y3 minus y1. So the fact that these triangles are similar is saying that it must be the case that y2 minus y1, the height of the little triangle, over the base of the little triangle, has to be equal to the height of the big triangle divided by the base of the big triangle. And that's a consequence of similar triangles. And what I want you to take away from that is that, in fact, it doesn't matter where you put any of these points as long as they're not on top of each other. They can't be the same point, because if they were the same point, then, well, for example, if x1 and x3, if x1, y1 and x3, y3 were the same point, then we'd be dividing by 0. So you couldn't do it. Similarly, I said that L needs to be a non-vertical line. Okay, why non-vertical? Well, right, so consider, like, you can imagine, I think, if I were to take this red line and wiggle it around like that, you'd see those right triangles moving to compensate. Right? They'd move a little bit. Then as I start taking the red and twisting it toward the vertical, then the right triangle is getting taller and skinnier and taller and skinnier and taller and skinnier until when you're vertical, it's no longer a triangle anymore. It's collapsed. Right? So it's not a triangle anymore. So this argument can't possibly work with a vertical line. From an algebraic point of view, if it were a vertical line, then all of the points that I selected would be lined up vertically, which means they would all have the same x value. Right? So then, in that case, in the vertical case, what would x3 minus x1 be? It'd be 0. So algebraically, we wouldn't be able to proceed because this would be a division by 0. So can you see that this concept that we're talking about, it requires non-vertical? Okay, so these 3 points can be any 3 distinct points whatsoever, right? I could take this one and pull it way far away. Doesn't change the result at all. So this this measurement apparently is important and intrinsic, and it's called slope. So this is called slope. And generally speaking, the way it works is that you take 2 points on a line, and then you measure the horizontal distance. So the horizontal distance is usually referred to as delta x, and so this is a signed distance. You know, because if you happen to be going, instead of going left to right, if you're going right to left, then delta x would be negative. So that character right there, that is a triangle. I mean, at least, you know, visually, but really that's a delta from the Greek alphabet. And what is the phonetic? What does a delta sound like? What letter does it correspond to for us? A D, right? So the reason for D is because difference, right? The difference in the x's. D for difference. This is also pronounced sometimes as the change in x. And here's delta y, like this. So 2 different measurements delta x and delta y, then the slope is usually denoted with lowercase m, and it is delta y divided by delta x, like that. And then in sort of street language, this is often called rise over run. Okay, so how much you go up divided by how much you go left and right. So concerning this, if we have a normal axis like this, so in this particular picture, is delta x negative or positive or what? It's positive. How do you know that delta x is positive in this picture? It's not. It doesn't matter that it's in the first quadrant. Is that the arrow is pointing to the right? Okay. And for this particular picture, is delta y negative or positive? Positive. Why? Because it's pointing up, right? So this particular that means that delta y is positive, delta x is positive, so the ratio is positive. So such a picture, such a line is said to have positive slope. So this is positive slope. And so a picture like this, you select 2 points. So in this picture, is delta x negative or positive? It's positive. Delta x is positive. In this picture, is delta y negative or positive? It's negative, right, because it's going against the world. And then the slope is the ratio delta y over delta x. So a negative divided by a positive, that's negative, right? So this is a negative slope. All right. Good. Any question about this? All right, so let's do an example. Okay, so I kind of singled out 2 points there. Okay, and what we have here is a line. Okay. Now, the request is for you to find the slope. Of that. So I'm going to demonstrate 2 different ways to achieve it. One is purely by way of calculation, and another way is without using a calculation. So to do it with just purely a calculation, we can say, well, I'll find 2 points there. So x1, y1. I'll read the coordinates of one of the points. So what are the coordinates of that point? -3, and then 2, right? So that's the coordinates of that point. What's the coordinates of that point? 2, -1. So now that I've read the coordinates of 2 points, I'm going to ignore the picture now. So I'm done with that. So now we need to compute the rise and the run. So delta x. Delta x, well, that's x2 minus x1, the difference in the x's. Okay, so now I'm gonna write something. that's not correct. So I see a 2, and then I see a -3, so 2, -3, right? Like that. What do you think? No? What's wrong with this? I put it in parentheses?
Yeah, because what you're saying is that the operation is like negative.
Right. So you can think of it like this. You could put parentheses here, and then you're supposed to fill in whatever the things go in there. So I'm supposed to put x2 in that first set of parentheses, and I'm supposed to put x1 in there. So x2 is 2, and then x1, this should be -3 like that, right? At any rate, that's one of the most common errors that I find, is that when one of the numbers is negative and you're subtracting it, somehow the double negation gets messed up. So this is 5. And then delta y is y2 minus y1. So again, it should structurally, look like this. And we just need to write in whatever goes there. So y2 is that, and y1 is that. So that'd be -3. All right, so now you might be worried, like, well, you might have read that to be x1, y1, and the other one x2, y2, which is to say sort of the opposite of what I did. And that'd be just fine, but the thing is that however you calculate delta x and delta y, these have to be in agreement, right? So what I mean is that it would have been just fine if we had done x1 minus x2 if we had also done y1 minus y2. Okay, so then, good. Then what's the slope? But wait, shouldn't it be 5 over -3?
But the slope is delta y.
Okay, good. So it's the change in y over the change in x. Okay. Another way to do it. So this is like sort of purely from the point of view of calculation. Another way to do it is to have a look at the plot. So from this point right here, if we wanted to get to the other point, then we could travel to the right 1, 2, 3, 4, 5 positions. So that's telling us that delta x is, well, should it be -5 or +5? Which one? +5. Why? Because we're moving to the right. And then to continue, I need to travel 1, 2, 3 positions. So that means delta y is what? Negative. Why negative? Because we're going down. Okay, so then reading the plot in that way, you know, or from the plot, you know, that's telling you that delta x is 5 and delta y is -3, and therefore the slope is -3/5. Any question about this? All right. Still, we don't yet quite know how to find the equation of a line. So now we need to get that wrapped up. So here we go. Let L be a non-vertical line. Let x1, y1 be on the line, and let m be its slope. So, you know, what we're saying is that we've got some non-vertical line, like this one, some non-vertical line, and x1, y1 is on the line, and it has slope m. All right, so that's the information that we have. Now, what I'm going to do is I'm going to choose any other point whatsoever besides x1, y1, just any other point. And since it's generic, I'm going to call it just xy. Well, because we use similar triangles to establish that as long as that xy is any other point except that one, it must be the case, in fact, that y minus y1, so that's the vertical change, the rise between those 2 points, divided by x minus x1, that's the run, the horizontal change, must be equal to what? Must be equal to the slope. Has to be equal to m. And that's true for any xy that's not x1, y1. So now I'm going to take that equation and multiply both sides. By x minus x1. And what happens on the left-hand side? We get a cancellation, right? So the x minus x1s cancel, and we obtain this. And here's an equation now, a formula that you're supposed to memorize. So this is called the point-slope formula. For a line. And, you know, that's a pretty good name because, well, the information that you have is a point and a slope. Any question about this? Okay, then we're going to do one quick exercise and then have a quiz. So here's the exercise. So, there's 2 points. Oh, I didn't want those points. That's fine, doesn't matter. No, I don't want those points. Ugh. I'm gonna do this one. So sorry about that one. Ignore that one. I didn't want it to go through the origin. So we want to find the equation of this line. So what things do we need to find the equation of a line? A slope and a point, right? Because we have the point-slope formula. Well, what's a point that's on the line? 3, 0. So I could say x1, y1 is 3, 0. And then how can we find the slope? Well, you can either calculate, right? Find another point and then calculate, or you can do the county bit. So I'll do the county bit since it's a little faster on this exercise. So 1, 2, 3, 4, 5, 6. So that's telling us that delta x is 6. And then 1, 2. So delta y is what? -2. So the slope is -2 over 6, so that's a third. And therefore we can find the equation y minus 0 is equal to -1/3 times x minus 3. So y is equal to -1/3 Whoops. Too many negatives there. Negative 1/3 x plus 1. Very good. So now let's have a quiz.